Hello, this is Camille Fairborn from Michigan State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. We're pleased to have as our presenter today Dr. Jun-Jin Lee, who is a professor of statistics at Soongsil University in Seoul, Korea. He's up very early in the morning to give this webinar for us. Today he will give a presentation entitled Mobile Teaching Statistics by Using the Web-Based Dynamic Graphical Software eStat. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box. We'll be sure to ask those questions towards the end and give the presenter a chance to respond. You can also use the chat box if you are having any technical questions. At this point, I'll turn things over to Dr. Lee. Dr. Lee, go ahead.
Okay, thanks, Camille. Thanks, everyone, for coming this webinar. My name is Jung-Jin Lee. I'm here in Seoul right now. It's very early in the morning, 5 a.m. in the morning. I say good morning, but you are good afternoon, right? Mm-hmm. Well, today I'm gonna discuss about the mobile teaching statistics. Here's one slide, one example slide for that. At the left-hand side, you can see some kind of a book. I'm sorry, it is a Korean book. It is not in English. Maybe in the future, I'd like to make the English version. On this book, there are many QR codes like this. If you visualize this QR by your smartphone, you can see me like this screen, I mean, like YouTube, like that. Also, if you visualize the QR in this way, you can see the software called eStat. What I mean is, while you are studying statistics, you can listen your lecture from your professors, or you can practice what you want. The point is, what kind of software it is, the eStat. I'm gonna briefly introduce what this project implies, and I'm gonna briefly overview the system, and then I'm gonna demonstrate eStat later, and I'm gonna show you several slides for mobile teaching, which is a real example. Then conclude something. Here's a motivation of my research. As we know, statistics is getting more important than any other era. Also, the statistical package for data analysis become very essential. Maybe all of you, if you are involved in statistic teaching, you would use some kind of software like SAS, SPSS, Minitab, R, like that. Me too, I am using in my classroom this software. One time I asked by myself, are you satisfied with this kind of teaching system for statistics? I said no, and I can make something better software than this one. I'm talking for teaching statistics. As you know, this kind of package is very good for data processing. But what I'm saying is, it is not enough for teaching statistics. Especially somehow, I have an interest in teaching the children, the school children. In the case, teaching software like SAS, R, that is almost impossible. One of the reasons why I have interest in teaching children, the Royal Statistical Society initiated this project, Census at School. Because of that, one guy in University of Massachusetts developed the Tinkerplot. And Tinkerplot is good for children, but in my opinion, not enough to teach data processing. And it is not a free software, and it has not much relation with the existing statistical package. Therefore, I have a target software which is something better than the current system. Here's my target. The software should be web mobile-based software. And then it should be more easier than current system. I mean, easy user interface would be more desirable. You will see that what does it mean. And then to amuse students, especially children, dynamic graph would be more helpful to invite them to the statistics world. Also, explain in detail. I found that in the school children's textbook, most of the data are summary data, not raw data. How can you handle that so easily? That's another mission to I'm targeting. Then you all know about the EDA by Tukey. I'd like to adopt that kind of Tukey design for statistical output. Also, I'd like to target about the e-learning system. Then hopefully I'd like to spread to all over the world. I like the philosophy of R. It's a freeware and everybody in the world can use that. I'm targeting similar system. Here's an overview about the system. Elementary school children, also middle school children, I'm gonna provide them just a graph. But you can plot graph by using the raw data at the same time by using the summary data like Excel style. Also, I found that high school teaching, maybe it's a Korea case, they teach binomial, normal, sampling distribution, law of large number, and confidence interval. I'd like to develop some simulation module to understand these things better. The main target is university level. I'll say the freshman, sophomore level, the elementary statistics. Here's my book chapters in my book. It is typical to all around the world. I mean, at the beginning, the visualization of data summary, then distribution function, sampling distribution, then all kind of testing hypotheses, single population, two population, ANOVA, non-parametric, categorical, then correlation regression. This is my target module to develop. After then, maybe you may use R. That is very so nice. That's for specialists, not for children or novice in statistics. What kind of technology I adopt? I used web programming, the trio, HTML5, CSS3, JavaScript. Also D3 library for dynamic graph. I adopted hands-on sheet. Then we developed many statistical libraries by about some statistical computing module we developed by ourselves. Many professors are involved, especially in statistical computing. There are 8 persons are deeply involved in this project. We are backing up by many professors in mathematics education and some school teachers. Here's a main screen of the system. Well, it is a little different from the SAS or SPSS style. At the top, there's a menu, but it is icon-only menu. I found that the school children often hit menu because they don't know what there are. Therefore, I used just icon design. And here's many examples I'd like to provide you. I'm going to show you in a minute. Suppose you have data. Here's a data source. I'll explain it some more. Then data come this sheet window. Then if you select a certain variable number, like clicking this column name, then you will see the graph. Also, sometimes if it is a statistical analysis, you will see the output in this area. Well, this design is for the university level. If you are elementary school student or middle school student, you can select your level. Also, you can select language. In case of university, I specially designed some educational module in this way. At the left-hand side, there are a bunch of distribution. I think I covered all of the elementary statistics course. I'm targeting you don't need any statistical table in your textbook. You can use your smartphone. I provide all kind of thing. I appreciate this, especially F distribution. In the classical textbook, you cannot provide all percentile of F. In this module, you can find all kind of percentile of F. Here's some simulation module to understand the statistic better. And here's some testing hypotheses. There's a simulation and some experimental modules are there. You will see that. Here's a key design of the eStat system. Well, the data, I just assume the Excel style, the CSV format. But if you are advanced user, you may use JSON format to include value labels like that. And then I adapt two kind of data. I call it this is a summary data, Excel style, which can be seen in the school books. You can easily plot graph like this. I mean, if you have raw data, just selecting column, you can have a graph like this. Another design, what I mentioned, Tukey style. Suppose you have an analysis of variance. If you select variable as usual in other statistical packages, the first screen is dot plot or histogram, which can compare the means. This is a starting point. And then you can see a regular ANOVA table. At the same time, you can find where is the observed value of F at this F distribution, 2 and 51 degree of freedom. I'd like to see from my teaching experience, it would be helpful to students. Here's an example of statistical distribution. I mean, these are the standard textbook, but same thing, you can do it on your smartphone. Also, in case of non-parametric statistics, because of computation, you cannot calculate all kind of probability. Here's one example of exact distribution of cross-cal values. It is amazing. I mean, within a second, you can calculate more than 10 million calculation and show this kind of exact distribution. Here's some module for homework assignment. I'm not sure whether you are agree with me, but there's a controversial, but I developed this one. On your textbook, at the end of each chapter, you have exercise problem. You can enter some data. You can have a similar output as the usual statistical package. Also, you can enter just this number. Then you have a same output like that. I'd like make a student can eat homework, but I'm not sure whether it is right or not. Here's some simulation experiment. This is a binomial experiment. This is for confidence interval. No, this is confidence interval. This is for central limit theorem. I'd like to demonstrate to you this system, but one thing you need to be careful is you may use any browser, but this software works 100% with Google Chrome. Also, you require HTTP, not HTTPS. Well, if you are online, you can start this software. Okay. If you type this address, you will see that this screen. Okay. Here's the main screen. The workflow of this software look like this. I stored many examples here. Okay. Well, you have, if you hit this EX icon, you can see this kind of menu. Here you select English folder. Then let's start the first example. Hit this one. Then you can see this kind of data. It's a very simple data, maybe elementary school, 2 classes, male and female, the sub, the count. The way we process this data is simply click variable name, and they'll provide you this kind of graph. Okay, this is for I'll say this is summary data. Well, not only this one. Suppose you are practicing some raw data. Let's consider math preference survey. Okay? You have data about the math preference, but it is classified by gender. Then click this analysis variable first. Then grouping variable will generate this kind of graph. Well, not only this graph, you can just push a button. These are the you can generate many graphs, but something is moving. Not only this one, maybe there's a variation of bar chart like this. You may have many kind of graph like this. Well, if you want to see the frequency table related with that, hit this button will generate a frequency table related with this graph. Maybe this portion is for elementary school student, and what are these icon imply? We accept the CSV file from your local computer. Also, you can load a file from your server. I provide this. In case of some advanced data structure called JSON, you need to hit this one. You can, if you generate data by yourself at this system, you can save it using this one. Well, let's go to maybe middle school level to the university level. Here's some continuous data. This data is some middle school teachers' age classified by the gender. In this case, I'd like to plot some kind of graph like this. Let's start from dot graph. How can I draw dot graph? Hit this column. Will generate some dot graph. You can explore the mean and standard deviation in this way, then you can check their statistic like this. This is a log window. You can later print it or save it using the HTML format. If you want to classify this graph by sex, it looks like this. Okay. Maybe you can have output the summary statistic in this manner, and you can compare. I mean, the mean. This is maybe Turkish style design. I mean, how it look like the data mean. You can compare before you get into, let's say, t-test. If you want to plot histogram, you can do it in this manner. So you can select this kind of frequency polygon, which is in the textbook in Korea case. Also, you can have a frequency table related with this histogram. You can switch the interval, whatever you like. Also, you can have a stem and leaf here, box plot, and so on. In case of a middle school in Korea, they teach the scatter plot. Let me show you how to load one data from GitHub. This is the address of GitHub, which has iris data. I copied here URL. You can enter your URL to load the data. Then have iris data like this. Let's try scatter plot. If you hit two columns, the first one is Y, second one is X coordinate. You will see this one. You can see the regression like this. Also, here's iris type. You can select a group, and you can plot a different color, the dot. Also, you can find the regression line. If you want to make one variable, something has a size on it, you can plot this kind of graph. I'll say this is middle school level. Now let's start the university level. And maybe where should I start? I have iris data like to the regression. Then they're gonna show this graph. I'd like to add two more variable. You have scatter plot matrix. You can have regression analysis as usual. And you can do residual analysis, residual plot, or whatever it is. It is a regular statistical package, something like that. Let me show you one more example about the analysis of variance. Here's data for 2A ANOVA. The ANOVA icon is here. Hit this one. Select first the analysis variable, then select factor. If you have a single factor, you would have output like that. This is Turkish EDA design. You can compare the mean. Here you have the ANOVA output like this. I mean, not only ANOVA output, you can have where is the F observation of the ANOVA table. If you add one more variable, then if you can have a 2A analysis of variance, they're gonna show you the standard graph like this, and then they're gonna give you the ANOVA test like that. This portion related with the university level, but they are similar to other statistical packages, except the first screen related with some kind of EDA. But this is enough. Therefore, I developed some university module This is high school special module. This is university level. You can see this kind of menus. It is related with all kind of elementary statistics. Let's start from binomial experiment. If you go to Science Museum, there's some experiment like drop the ball at the top. They'll split into two pieces and keep going on. They're gonna show you some kind of binomial distribution like that. When I lived in state, I saw this kind of experiment at the Science Museum. Okay? I'd like to make a simulation to show to children by using this kind of software. Here's a tossing a coin problem like that. Okay. If something is dynamic, I bet, there are some motivation the student can study statistics. For this one, you can have a binomial distribution and you can explore the possibility like this. Okay, you can check the normal approximation. You can have a corresponding binomial probability table, which is typically seen at the textbook. Well, you can have some normal distribution similarly like this, and you can check the probability in this manner. You can calculate a percentile using this kind of menu design. Also have a normal distribution table, normal 0-1 table as a usual statistical textbook. Also, you can have some percentile table, which is, I think it is better. Yeah, it's a percentile table. Well, I provide you most of the discrete probability continuous case. You have T chi-square F. Personally, I like the F distribution in this way. Okay, you can explore the shape of F distribution. I didn't see exactly how they look like, but I can do experiment and I can calculate any kind of probability. Also, you can check the non-parametric distribution like this. Here's some simulation module to teach statistics. This is for high school student. What is if you toss a coin 1,000 times, how many heads will appear? And here's a simulation example for confidence interval. Well, you can do simulation over and over. I'd like to show student what it would be if you repeat 100 times. How many of them will include the population mean 0 and how many are not? You can keep this experiment. That's the meaning of the confidence level. One thing I like here is the regression experiment. While I'm teaching regression, well, I emphasize the residual analysis. Suppose you, well, it has the correlation 0.7. By moving this point, you can check that just a single point can influence a lot about the statistical analysis. That means you need to get rid of the outlier. Let me show you one more example about the testing hypothesis. While I'm teaching the testing hypothesis, well, student doesn't understand well about the alpha and beta. Let's say if you have this data, they're gonna first to generate the testing hypothesis graph. Now you can experiment that, what the alpha look like. Okay, if you change n what it look like if you change alpha, what the decision look like. I'd like show this graph to children. Another thing maybe I can show would be what? Let's experiment non-parametric. Here's Kruskal-Wallis ANOVA in non-parametric case. You enter data like this. And hit this button will generate a statistic and Kruskal-Wallis distribution, and where is your observation located. You can make a decision easily. Okay, this is a rough demonstration. Let me finish my talk. By using this software, I made a book. Here's a couple of slides for them. This is for data visualization. Traditional textbook just to show this kind of graph. But by using QR code, the smartphone can visualize any other practice related with this data. The same thing, this is Korean character, I'm sorry, but you can realize the international language, what is the percentile of normal. You can do it by using your smartphone at classroom. Also, two group t-test. Here's a summary statistic. By using this, if you enter this one, you can have output. I bet it's helpful for students to understand. Same thing for ANOVA. You can do that. And some non-parametric test like this. This is a regression module. Okay, here's my conclusion. As I said, I am not satisfied with the current teaching style. I mean, traditional textbook and with the SPSS R or SAS. Rather than that, for the elementary statistical level, I'd like to use this eStat. But not only elementary school students, I'd like to make a software such that the children in elementary school can also use this kind of software. There's a continuation from the elementary school to university. That's what I want. Currently, this software is recommended by Japanese Statistical Education Board. And somehow this one spread to worldwide user because it has already 10 translated languages. Here's some domain for that. There's some audience from USA, some others from Russia, Europe, and so on. I'd like to continue this free eStat project. I have 30 years of teaching experience. Some of you might have a better experience than me, or you might have a better idea. I'd like to invite you to join this project. It is non-profitable. We'd like to help the student to understand the statistics. Well, thanks for listening my talk. I appreciate your coming to the webinar again. Thank you.
Well, and thank you so much for sharing this with us. I've been really impressed with the demonstration of the software and how much variety you have in your examples and the graphs and things. Okay. Let's turn it to the listeners. If you have any questions for Dr. Lee and you'd like to put them in the questions box, I can ask those. The one question that I do have so far is there an English version of the teaching module?
Well, the software has English version, but the book, no, I'm working on it.
Okay.
It's not ready yet, yeah.
So you are planning to translate your book into English?
Yes, I'm going to. Maybe if some of you has an interest in, we can do simultaneously. We can do joint work. Yeah.
Okay. I had a question and now I'm still waiting for other people to come in with their questions. Oh, my
Okay.
question was, how much of your development of this was motivated by needing to have teaching materials that were in Korean? Because I noticed there's pieces that I've seen in other people's softwares and projects in, English, but I'm just wondering for you how much of it was a language issue.
You mean my
Like
personality? Or,
your motivation for starting the project.
aha. Well, I have a teaching experience in United States or some other countries, also Korea.
Hmm.
Well, the main motivation is teaching statistic for statistic major. There's no problem to teach R or SAS, whatever it is.
Hmm.
But if you try to teach statistics to non-major, like business college or some children, you would have a difficulty about the current style teaching. That's
Yep.
the main motivation. Yeah.
Okay. All right. Well, another question was, do you know if eStat is being used by teachers in the Philippines?
Mm-hmm. Yes, some of them are using that. Yeah, already.
Well, I love how multicultural this is and also how deep you can go with some of it. I was just playing around with it a little bit while you were demonstrating, and there's just so many interesting things that you have there.
Yeah.
So thank you again for presenting and sharing this with us and for making it free for us all to access. That's very generous and we appreciate that. And
Okay.
Dr. Lee was telling me earlier that he will be at USCOTS next month. If you want to stop by the poster session, he'll be there. And
Yes.
yeah, and I
Yes.
know that Dr. Rossman is hoping that everybody will hurry and register for USCOTS so they can have an idea of how many people are coming. So I'll put that plug in there as well. And again, thank you, Dr. Lee, for doing this today. Thank you all for coming, and I hope you have a great evening and rest of your day.
Okay. Thank you very much. Yeah, I appreciate it.
Thanks again.
Mhm.